Okay, this is the video for AngstromCraft. Mm, yes, so now we have a clean directory. So just make a build directory and go to build and make and make. Okay, the reason why I start from this make and execution is now it will take some time to execute this Armstrong crypt file. So during its execution, so I will just explain the implementation. Okay, now you can see that the simulation domain is a little bit larger, 22 by 18 by 60. You know, it's not that actually large, but my implementation is quite inefficient. So without considering any efficiency, so it is found that it takes quite a long time. So what I do right now is like this. Just to make the simulation domain and just to save it. So we will have only container bedrock. And after that, we just did some jobs as of yesterday. So after this is over, this is file epi.cgns file shows epi structure. Now we must make a certain etching process. For that purpose, I introduced today the mask here. So its size is given as the same with the craft. So this one does not say the entire region is masked, but the total size is given as this number. After that, I just set rectangle and its position is given as these two points 5,0 and 17,18. So these are two uh, points in our rectangle, and yes, in some sense, left lower point and right upper point. And for that case, I will just add 54 labels, yes, and we will have just etched.cgns. So this set, the rectangle specified, this set rectangle is protected, and the other parts are etched away. So let's just have a gap. Okay, so I guess that this is just over, uh, but for your interest, let's just visit our mask.h file. So now mask just have whether that is masked or not, and we have its implementation. Then when we have an x and an y, in order to consider bedrock, we add number 3 for x direction and y direction, and initially the false masked variable is uh, created. After that, by calling this set rectangle, then this part is just flipped into the true. So now we have the information about mask. After that, etch is done. So how does this etch routine looks like? This was an anisotropic deposition, and now we have an anisotropic etch. So it's quite simple. We just repeat the thickness times, and for our entire simulation domain, we learn, but in this case, we ask ourselves where this ix comma iy point is masked or not. Only when it is not masked, then we call the pointwise etching process. So now we have that part is etched away. So let's just go to epi.cgns. So you will see the exactly same as before. So now you have this structure, and let me just eliminate this bedrock and only show you uh, the different colors. So now you can see that these blue ones are corresponding to channelization, and this green one, this is corresponding to sacrificial layer, and substrate red one, and yellow one is capping layer. So okay, it looks good, but from the top view there is no patterning at all. That was the situation of yesterday's video. So now let's go to, instead of this one, now the, the profile after etching, masked etching is shown in this file. When we visualize it, it looks a little different. So just to eliminate the bedrock and now show cubes and say okay, now you can see that this part and this part is etched away, and you look at this one. Yes, this part is masked, so now you can see there are still capping layers, and now here blue, lead and lead parts are corresponding to the substrate. I just selected the exact number to etch step here. Of course, if I increase the number of thickness, then even this substrate will be etched away. Bedrock is not etched away, but substrate, that is nothing special. So now you can see that yes, this is quite clearly etched, whether that is masked or not. So is it because this is really anisotropic etching? Only one directional etching is done without considering any kind of uh, isotropic behavior. So later task is to make a certain etch, selective etch of this sacrificial layer. This sacrificial layer should be etched away, however, not completely, slightly etched away to provide us some spaces uh, for spacers. But right now, we don't have any capability for isotropic etching. So I think that and I'm afraid that I need some time to implement those capability. Okay, when I implemented that isotropic deposition and etching capability, I will immediately come back to you to share the progress. Okay, thank you.